that looks like, yeah, I think you always get something that looks like you replace your non-dynamical variable, and it's that non-dynamical variable times a constraint. This was actually sort of a question we had a while ago, right? And I figured out how to see it, I think, because, okay, I was trying to write this out in very general language, and then I sort of got too general to even say anything.
Okay.
So let me see what I had. Okay. I was trying to...
So you're doing some category theory or
No.
something?
But I was like trying to sort of the most general Lagrangian, and then I was like, no, that's sort of too general. Because I wanted to start with a Lagrangian that looked like E and M. So, but I think there was a time where I got to something kind of cool, where it was like, oh, obviously this happens. It's because, yeah, basically the idea is, right, this is the idea, yeah. So you take, so say, what is it? It's that your map
I'll be right back. Keep talking about it.
between, okay, let me see if I can think of the simplest way to say this. So I've got, so it's like, what's pi? It's partial L partial Q dot, right?
Mm-hmm.
And so if Q dot is linearly in
L?
L,
Yeah.
then this map is not going to be invertible, right?
Right, 'cause
That's
it's-
sort of the
yeah.
problem. But that means, like, so that the case where it's going to not be invertible is where Q dot is linearly in L. And so that means when you do the Legendre transform, what you're going to get is you're going to get Q dot. So that means you have Q dot times your constraint
Oh,
in your Lagrangian. Because this ends up being, something like this ends up being your constraint equation. Or,
right, yeah.
and so,
Yeah, okay.
so,
Certainly if it's zero, but
well,
even,
so,
but even if
so
it's
no, it's that, so this, so if, so let me figure out how to say this. Okay, so let's start with a Lagrangian that looks like Q dot I, this should be Mij,
yeah, okay.
Q dot J, right? And then plus, you know, M
Linear stuff.
squared, Q squared or something like that, right? I don't know, something,
Yeah.
where, you know, this could be a matrix too, but let's just assume it's not, so we're sort
Well,
of
yeah, I mean, the point is if you can't kind of diagonalize that one, then it's like the Q wasn't there in the first place, and so,
yeah,
like, you shouldn't be addressing it. It's like,
Yeah.
or
yeah, so I'm just gonna assume that we've diagonalized our
Yeah.
mass term,
yeah,
and let's say they're all the same mass, so that, because then you can just sort of treat them all separately if they're different mass, probably. Partial L, partial Q dot I, so that's what our momentum is gonna be,
this is why you want a 1/2 out there, probably.
Mij, yeah, 1/2. Yeah. It's gonna be, so let's say Mij is symmetric, right? So that we don't have to deal with
Yeah.
that. So, okay, so it's gonna be Mij, Qj, right?
Yeah,
Okay, so now, the constraints are gonna be determined by, so now we wanna sort of look at, right? We wanna look at
oh, and that's a,
what the
that's a,
rank of
that's
this
a, and that's a
matrix
dot,
is.
that's a dot on the QJ.
Yes, yes. So now we wanna look at what the rank of this matrix is, right? So this means, okay, so I think the idea is you can always sort of find a basis where it's just that your sort of pi's are 0 or something like that. But even if your pi's aren't 0, is that right? No, okay, because sometimes you can mix in between
So the example that you did was one where we had like a mixing of those two type of terms.
Right.
So we had a dot and a Q.
Right, that was the example we did. Well, okay, what am I? But I'm thinking of another example, and didn't have a mixing.
But
Oh,
yeah,
no, it did.
if you
It
just
did have
get
a
0,
mixing.
then I can see the thing that you were arguing.
Yeah. So
as
if
being
it
the
looks
punchline.
like this, then I think you have to get 0. Okay, so what's the more general thing then? So it's, say we've got some matrix, something like some block matrix thing, right? So this is Q. Let me just do it like this.